Hello geometry students. In this video we're going to learn about the triangle exterior angle theorem. So it's important to know what some of these terms mean. It says the exterior angle of a triangle is equal to the sum of the two remote interior angles. So an exterior angle is if we were to extend one side of a triangle in one direction to make straight lines. So kind of like over here on this side, I'm going to make this angle right over here, angle 4. That is an exterior angle, and it's the sum of the two remote interior angles. The remote interior angles would be the interior angles that are not adjacent to this angle, not the one that it forms a linear pair with, but the other ones. So in this case, angle 2 and angle 1. And in our triangle over here, I want to show you how this happens. We have a triangle with angles 1, 2, and 3 interior, and we've got this angle 4 over here on the exterior. If we could move angle 1 and angle 2 over here, then they should fit exactly in the space where angle 4 is. So let's try that. Let's slide angle 2 right over here. And then let's take angle 1. Well, if we slide it over here, it's not quite going to fit, so we need to rotate that angle. But if we rotate that angle right there, then we can fit it exactly in there. And you can see, let me rotate just a little bit more. You can see that my angle 4 is equal to angle 1 plus angle 2. Sorry, mine didn't come out quite exactly right there, but I hope you can see. There we go. Now I've got it in there. So the exterior angle equals the sum of the two remote interior angles. So let's try some problems. Find the measure of the missing angle. Well, we have here where our missing angle is an exterior angle. We're looking for this angle out here, and it's going to be equal to the sum of the two remote interior angles, this 60 and this 70. So our x equals 60 plus 70, which is 130. Simple. Example number 2. We're trying to find this angle right here. It's a exterior angle, so it's equal to the sum of the two remote interior angles. It's equal to 35 plus 92. So our missing angle over here is just 35 plus 92. And when we add that up, we get 127 degrees. Simple. Example 3. Now, a different setup here. We've got our exterior angle is equal to the sum of the two remote interior angles. This time, our x is an interior angle. So our setup would be, and let's make sure to note here that these are the two remote interior angles. So our setup is that the exterior angle is equal to the sum of the two remote interior angles, x plus 104. And when we solve that, we get that x equals 26 degrees. And one more problem before we get into some algebra. Same idea here. We have got this exterior angle is equal to the sum of the two remote interior angles. So the exterior angle equals the remote interiors, here's our x, plus the other one is 70. That gives us that x equals 60 degrees. Now I'd like to note that if you wanted to verify this, you could. If you plugged in the 60 right here, 60 and 70 makes 130. We could find the other missing angle inside of our triangle because we know that all three angles inside a triangle add up to 180. So if this 60 and this 70 equals 130, that means if we subtract that from 180, this angle would have to be 50. And then with our linear pairs, we know that 50 and 130 do make a linear pair because they are supplementary. Just kind of a check. On these problems, you could solve it the long way around, but that's really taking a couple of unnecessary steps. Now let's do a few where we don't have that option of just adding up our numbers. We have to use algebra here. So let's take a look. We've got our exterior angle here is 128 is equal to the sum of the two remote interior angles. This r, which is 6x minus 8, and angle s, which is 8x minus 4. So 128 equals 6x minus 8 plus 8x minus 4. And when we solve this, We could use algebra or we could use Desmos if you want to use algebra. I encourage you to pause the video right now, solve. Or if you want to use Desmos, pause now, head over to Desmos and type this equation into Desmos. Or using algebra, either way, you should get as your solution value of x equals 10. For our next problem, we've got another exterior angle is equal to the sum of the two remote interior angles. So the exterior angle, 120, equals the sum of the two remote interior angles, 6x minus 2 plus 5x minus 10. Just for fun, let's go ahead and do the algebra on this one. If we were to solve this by algebra, 6x plus 5x makes 11x, negative 2 and negative 10 makes negative 12. If we add the 12 to both sides, then we get 132 equals 11x, because that cancels. And then if we divide by 11, we'd probably want to use our calculator here, unless you're really good with your multiplication tables. This gives us a value of 12. So x is 12. For our next problem, we've got this exterior angle here is equal to the sum of the two remote interior angles. So we just need to set up the equation. 18x plus 8, that's the exterior, equals the sum of the two remote interior angles. 4x plus 4 plus 88. Just for fun, I'm going to go over to Desmos now, and I'm going to put that in and see what we get. If we put in 18x plus 8, that equals 4x plus 4 plus 88. And what happens is Desmos solves it and tells me right there, x equals 6. Where we have that vertical line, that x value, that's what x equals. So this gives us, when I use Desmos, we get that x equals 6. And one more of these. Again, we have an exterior angle and two remote interior angles. The exterior angle is 28x minus 4. The remote interior angles are 52 and 16x plus 4. So exterior angle equals the sum of the remote interior angles. And whether you use algebra or whether you use Desmos to solve this, once you do the work, which you should do right now, you should pause and either work it out by algebra or work it out with Desmos, you end up getting that x equals 5. And that's all we have to do for the exterior angle theorem. If you have any questions, bring them to class next time. Bye-bye.